This is number 24 from section 2.3. We're given two functions named u and v and told that those functions are differentiable at x equals 2. That means we can find a derivative there. Then we're asked to evaluate these derivatives of the functions that are comprised of u and v at x equals 2. So let's get started with part A. We've got the derivative of a function that is given by u times v. So we know to differentiate that function, we want to use the product rule. The product rule says take the first function, in this case u, multiply by the derivative of the second function. That would be v prime. Then we're going to add the second function, v times the first function's derivative, which is u prime. Then what we do from here is we want to substitute in the values of these functions at x equals 2. In other words, we're going to do a u of 2 times v prime of 2 plus v of 2 times u prime of 2. So let's make those substitutions. U of 2 is 3, while v prime of 2 is 2. And then we're going to add v of 2, which is 1, times u prime of 2, which is negative 4. So we have a 6 plus a negative 4. Answer to part A is 2. Let's move to part B, where we have a quotient of the functions u and v. This is u divided by v. So we know we're going to use the quotient derivative rule, and that goes like this. The low function v times the derivative of the high function, which will be u prime, minus the high function u times the derivative of the low function, which will be v prime. And then this is over that denominator, or the low function squared. So I'm going to skip the step I did in part A where I showed what I would be substituting and just head straight to the substitution. So v of 2 we know is 1, while u prime of 2 is negative 4. Minus u of 2 is going to be 3, and then v prime of 2 is going to be 2. And then this is all over v of 2 squared, so that's just a 1 squared. So what do we have? A negative 4 minus a 6 over a 1. So our final answer here is negative 10. Let's move to part C. It's a similar question to part B. We have a quotient again. This time it's v in the numerator and u in the denominator. So our derivative will be slightly different. It's going to be u times v prime minus v times u prime. And this time it will be over u squared. So let's do the substitutions. U of 2 is 3, while v prime of 2 is 2, minus v of 2 is 1, times u prime of 2 is negative 4. And then we're over u squared, so u of 2 is 3, and we're going to square it. So we have a 6 plus a 4 over a 9, and that means our final answer here is 10/9. Finally, part D, the derivative of 3u is simply just 3u prime. We use the constant multiple rule to bring the 3 along with us. And then we're going to be a minus 2v prime. And then the 2uv we're going to have to treat as a product rule. So I tell you what, I'm going to move down here so I have a little bit more space. 3u prime minus 2v prime, and then plus 2 from the constant multiple rule, but then we're going to have to do a product rule on uv. So that's uv prime plus vu prime, and then let's go from there. So this is 3 times u prime of 2. U prime of 2 is negative 4. So we have a 3 times a negative 4 minus 2 times v prime of 2. V prime of 2 is 2. It's a minus 2 times a 2 plus 2 times. Now we've actually already differentiated this and plugged in u of 2, v of 2, u prime of 2, v prime of 2 back in part A. And the answer to part A was 2. So I'm just going to plug in a 2 right there. So here we go, a negative 12 minus 4 plus 4. That means our final answer to part D is negative 12. And that's number 24 from section 2.3.